Well, hello, algebra. This is 4-4, family of lines. So here we have a lesson on parent graphs or parent functions. So you'll need to take some notes, and you'll need some graph paper to graph some of these things. So what we're going to do is talk about parent graphs. The parent graph is the simplest graph in a family of graphs, and a family of graphs includes equations of graphs that have at least one characteristic in common. The characteristic differentiates the group of graphs from other family graphs. Some family of graphs you will study in high school are the linear family of graphs. This is the linear parent function right here. And the quadratic family looks like this. And then the absolute value family. And you will study them with respect to their respective parent functions. So you want to draw this. This is y equals x. This is the linear parent graph, and it always looks like this and goes through the origin. The slope is 1, the y-intercept is 0. This is the quadratic function. So anytime you see y equals x squared, it will be a parabola that looks like this. And then this is the absolute value function, so y equals the absolute value of x, and you will get a graph that looks like that in some form or another. So today we're going to discuss the linear family of the family of linear equations. So the parent linear function is y equals x. Y equals x. Or you'll see it as f of x, function of x is equal to x. Remember, f of x is the same thing as y, where m, the slope, is equal to 1, and the b, or the y-intercept, is 0, 0. So this is the parent function. So the characteristics that we will differentiate are the slope and the y-intercept, and we're going to see how the different slopes make the parent function shift, and the y-intercept will make it shift as well. So let's look at some examples. Alright, so the first thing that we will look at is we are going to compare equations to the parent function. We want to look at, is the slope increasing or decreasing? So in the equation, this is the parent function, y equals x or y equals mx plus b. If m, that's the slope, if m is positive, so if m is positive, then the line is increasing. And you can see over on to the right here, that this is an increasing line. So this is a positive line where the slope is positive, so the line is increasing. If you see that in this equation that m is negative, and I'll just put neg for negative, then the line will be decreasing from left to right. You always want to read these from left to right. So you'll notice here that this is a decreasing line, so it has a negative m. M is negative. Next thing you want to do when you're comparing functions is look and see the steepness and the flatness of the line. So you're going to compare steepness versus flatness. So in the equation, y equals mx plus b, if m, the slope, is equal to 1, then the slope is the same as the parent function. So you can look over here and see the blue line. That's the parent function. That's, if it has the same slope, it will be just like the parent function. If, on the other hand, so if m is, let's see, less than 1, but greater than, it has to be greater than 0. So in other words, if m is a fraction such as 1/2, or m is, 2/3, any kind of fraction, then the slope will be a flatter slope than the parent function. And you can see here, which you should probably color code and have this in your notes, that this slope will show a slope that is less than the parent function. So it's less than 1, but it's not negative, because if it was negative, it would be decreasing. It's between 0 and 1, so it's a fraction. The other kind that you will see is if m is greater than 1, so m is greater than 1, so m could be 2, m could be 3, or whatever, then the slope will be steeper than the parent function, steeper. And you can see that this is a steeper line that's positive. It's going up from left to right, but it's steeper because the slope is greater than 1. The other thing that we want to compare, the next part of this, is we're going to compare is the y-intercept, that means where it crosses the y, is it shifted up or shifted down compared to the parent function. So notice where the parent function is. The parent function is, is here, right? That's the parent function. So what we're going to look at is we're going to look at the y-intercept. So if, first of all, the y-intercept, which is b, if b is 0, then the line is not shifted up or down. So if it's 0, that means it will go through the or through the origin right here. So if the slope is 0, it will, not the slope, the y-intercept is 0, then the line will go through the origin, and it is not shifted up or down. If in the equation, if the b is positive, so it's bigger than 0, it's positive, then you can see that the line will be shifted up. So it'll be just shifted up to whatever the y-intercept is. So the line is, I guess I should write that in there. So the line is shifted up. So write that down. So if the b is positive and bigger than 0, then it's shifted up. And if the b is negative, let's say you have a negative b, the line will be shifted down. And you can look over to the side at the graph and you can see that this one, pink line here, is shifted down and crosses the y-intercept there because it has a negative y-intercept, whereas the green has a positive y-intercept, so it's crossing above. All right, so this should be in your notes with the graphs. Hopefully you've kind of color-coded as well. Okay, so now we're going to fill in this chart. So you'll need to copy it, and you can print it out if you want, and then copy it down into your notebook, and then we'll fill it in, and you'll need a piece of graph paper as well. So what we're going to do is we're going to take these equations over here. We're going to identify the slope, identify the y-intercept, and then we're going to compare this to the parent function, and we're going to decide, is the slope the same, steeper, flatter, is the slope increasing, decreasing, and is there a shift of the y-intercept up and down? And then we're going to graph everything down here. So, and I'm going to color code with a red, green, blue, orange, and purple, but you can use whatever you want, okay? So get all your supplies together and pause this, and let's get started. Now remember, I do want to note, remember that the basic equation is y equals mx plus b, which is the same thing as the parent function. Remember, the parent function is y equals x because m is 1 and b is 0. Okay, so this is called the y-intercept, but it's also your basic function. All right, so if I look at y equals x, I know that my slope is 1. Oh, I'm supposed to do red, so hold on, let me erase that. All right, so my slope is 1. If you look down here, the slope is 1. My b is 0. And then my y-intercept, whenever the b is 0, that means your y-intercept goes through the origin. And this is the parent linear function. So this one is going to go right here, goes through the origin. The slope is 1, up 1 over 1, up 1 over 1, and so on. So I'm going to pause this and draw it. Alright, so this is the best I can do with a line on mine, but this is the basic parent function with a slope of 1, and then it goes through the origin. All right, let's look at the next one. The next one is y equals 2x, and we could see that the slope is 2. Remember, that's your m is your slope, and then the y-intercept is 0. So that means it goes through the origin anytime the y-intercept is 0. And then we want to see, is the slope the same, steeper, or flatter? And it's going to be steeper because the m is greater than 1. Is the slope increasing or decreasing? Well, because it's positive, it's increasing. And is there a shift up and down? And no, there is no shift because the y-intercept is 0. So now I'm going to graph this, and you can too. Okay, so this is my green line, which is y equals 2x. Okay, so next we're going to do this equation, y equals 2/5 x. So my slope is 2, oh, wrong one, back. Won't let me erase that, I hate that. All right, I'll just do 2/5, that's my slope in blue. And then my y-intercept is 0, so that means it crosses through the origin at 0, 0. And if I have a fraction as the slope, it's less than 1, that means that the slope is flatter than the parent function. And because it's positive, it is still increasing, so I have an increasing line because I have a positive slope. And there is no shift up and down because, again, my b is 0, and it goes through the origin, so there's no shift. All right, now I'm going to graph that as best I can on this graph. Rise over run, rise of 2, so up 2 over 5, 1, 2, 3, 4, 5. So a point there, then up 2 over 1, 2, 3, 4, 5. And then I have to go backwards, which means I go down 2 over 5, 1, 2, 3, 4, 5. So there, and down 2 over 5. Oh goodness, I think it's there. I hope I did that right. 1, 2, 3, 4, yeah. All right, now I'm going to connect the dots and draw the line. All right, not the prettiest of lines, but it does work, and so we see that that is a slope of 2/5. So you can really see that the green one is steeper, the blue one is flatter. All right, now we're going to do y equals negative x, and y equals negative x, what is the slope? The slope would be negative 1. And the y-intercept again is 0, so it also goes through the origin at 0, 0. And the slope is actually the same, okay, because the slope is negative 1 to the parent function was 1. The difference is that now we're decreasing in the line. So it has the same slope, it's just decreasing. And there is no shift because the y-intercept is still 0. So in order to graph this, we would start at the origin and go down 1 to the right 1, down 1 to the right 1, and so on. And to go backwards, we would go to the up 1 and then to the left 1, up 1, left 1, up 1, left 1, and so on. And then draw the line through there. So there we have a slope with a negative 1. Now the last one, we have a slope of a negative 3x. So the slope is negative 3. The equation is y equals negative 3x. The y-intercept is 0. And the point is 0, 0. Is the slope the same, steeper, or flatter? Because it's a 3, it's not flatter, it's going to be steeper. Excuse me. And because it's negative, it will be decreasing. And again, the shift of the y-intercept up and down is none. So if we graph this in purple, we'll be able to see the slope is negative 3. So we do negative 3 over positive 1, start at the origin, go down 3 and over 1, down 3 over 1, down 3 over 1. Then if we want to go the opposite direction, we would go up 3 and left 1. Up 3 and left 1. Up 3 and left 1. And then we'll draw a line through it. And now we have all of these equations graphed, and we can compare them all by their slope, by whether the line is increasing or decreasing, and whether we have a shift up and down. And you can see all of these went through the origin here because all of them had a y-intercept of 0. Hopefully that made some sense to you. Now we have one more section where we're going to compare the y-intercept and check it out. Okay, copy this this chart into your notebook or print it out, and then we'll fill it out together. This is family B. Now we're going to compare, these are equations, and I believe we're going to compare y-intercepts. So we'll start with the parent function, and the parent function is y equals x. The slope is 1, the y-intercept is 0, which means it goes through 0, 0, and that's our parent function. And if we graph it, we use rise over run of 1 over 1, up 1 over 1, up 1 over 1, and then we can go backwards and do down 1, left 1, and so on. So this is our basic y equals x parent function. It's a little crooked, I apologize. Okay, let's go on to the next one. We're going to use green now, and we're going to do y equals x plus 2, the second one here. Our slope is again 1, and this time our b is 2, which means our y-intercept is at 0, 2. So if we plot this, then we can see it has the same slope, except we start at 0, 2. So I'm going to start here, and I still go up 1 over 1, up 1 over 1, and so on. Up 1 over 1. And then I can go backwards and go down 1, left 1, down 1, left 1. So let's graph that. Okay, so then what you notice is that the green line is basically the same. It's parallel to the red line, except it's shifted up 2 places. So the slope is the same? It is the same because the slope is 1. Is it increasing? Yes, it's increasing just like the other one is, just like the parent function, I should say. And is there a shift? Yes, we shifted up 2 from the origin, which makes sense because my b was positive 2. All right, the next one is x plus 5. Again, the slope is 1, the b is 5, which means the y-intercept is at 0, 5. Does it have the same slope? Yes, same slope. And because it's positive, the slope is positive, it is increasing just like the parent function is. Now the difference is that we're going to shift the line up 5. And let's show you how you do that. So where we start graphing this is at 0, 5, which is here. So it's basically the same line as the parent function, except it's shifted up 5. Our slope is 1, so rise over run, up 1 over 1, up 1 over 1, and so on. So graph that, and you'll be able to see it. So there is our y equals x plus 5 line, and you can see it's parallel to the other lines, just shifted up. All right, let's do the next two. All right, the next line is y equals x minus 3. Again, the slope is 1. The b is negative 3 this time, so your y-intercept is at 0, negative 3. The slope is still the same, and now because we have a same slope exactly, it's still an increasing line. The difference is now that it is just shifted down 3 because of the y-intercept. So you start here at 0, negative 3. 0, negative 3 is here. But you have the same slope, which means you're up 1 over 1, up 1 over 1, and so on. And so you can see that this line is going to be parallel to the parent function and all the other lines, except that it's just shifted down. So I'll pause this while you graph it. And there it is, a little bit straighter than the other ones. All right, the last one is y equals x minus 6. Slope again is 1, and the b is negative 6. Y-intercept is 0, negative 6. Slope is the same, still an increasing line, only now what has happened to the shift. The shift, we're going to go down 6 because of the b is negative 6. So you would start graphing at 0, negative 6, which would be there, the same slope. So if you know the drill, go ahead and finish this out and check it. And there we have the purple line, which is parallel to all the other lines. So one thing you might notice to summarize is that if you have the same slope, you will have parallel lines. So if they have the same slope, you have parallel lines. And that's something we'll discuss a little bit more down the road. So in summary, you need to know that what the parent function is, y equals x, that it goes through the origin, that anytime the b is equal to 0, that the line will go through the origin at 0, 0, and the b will determine where it crosses the y-axis, whether it's shifted up or down, and then the slope will determine the steepness of the line. The bigger the slope, the steeper the line. If the slope is a fraction, it will be less steep, it'll be flatter. And if the slope is 1, it'll be the same as the parent function. So there you go. There it's summarized. Sorry if it was a little bit long. You do need to do a whisk. When and where did you watch the video? Summarize what you've learned and any questions that you might have. Have a wonderful day.